Welcome and thanks for joining me for another episode of How to Algebra. Not the only place, but the best place to learn the finer points of algebra. Today we are looking at adding, subtracting, and multiplying polynomials. So if you haven't done so already, please subscribe, comment, like, let me know what you think. And I will catch you in the next video. Let's get it. Okay, adding and subtracting, multiplying polynomials. Let's start with adding. So adding polynomials vertically and horizontally. Adding is always going to be the more ideal situation because you're just combining like terms. Here we have add 2x cubed minus 5x squared plus 3x minus 9 and x cubed plus 6x squared plus 11 in vertical format. So basically we're going to align the two polynomials vertically and then add like we all know how. So, all right, so notice that there's no x term in the second polynomial. So we have to leave a blank space to account for that. So adding like normal, we're going to get negative 9 plus 11, positive 2, positive 3x, negative 5x plus 6x will be plus x squared, and then 2x cubed plus x cubed is 3x cubed. So again, we're simply combining like terms. Horizontally, this will be, again, combining like terms, except we're not aligning them vertically. All right, so here we're adding 3y cubed minus 2y squared minus 7y plus negative 4y squared plus 2y minus 5. When you're adding two polynomials, we are just combining like terms. So here the parentheses are basically irrelevant. So here we only have one y cubed term. So 3y cubed. We're combining the y squared term. So negative 2y squared minus 4y squared. Combining the y term, negative 7y plus 2y. And then there's only one constant. All right, so subtracting polynomials is a little more difficult than adding, only because that second term that you're subtracting, the negative or the minus has to distribute. So we're going to subtract 3x cubed plus 2x squared minus x plus 7 from, right, this is a pretty important word, 8x cubed minus x squared minus 5x plus 1 in vertical format. So we have to understand what number is going to be on top and what number is going to be on bottom. So we're subtracting the first one from the second one. Okay, so we're going to distribute the negative through the second polynomial, and then basically we're going to add. Once we distribute the negative, we're going to combine like terms by adding. So this is going to be 1 plus negative 7, basically 1 minus 7, negative 5x plus x, negative x squared minus 2x squared, 8 plus negative 3x cubed, 8x cubed minus 3x cubed. All right, our fourth example, we're going to subtract 5y squared minus y plus 3 from 4y squared plus 9y minus 12 in horizontal format. So the first one from the second one. Okay, so remember that the negative has to distribute. So 4y squared minus 5y squared, right? Because after we distribute the negative, it basically becomes addition at that point. Or we're combining rather. So this is going to be negative y squared plus 10y minus 15. So the big takeaway is that when you're adding, you're just combining like terms. when you're subtracting, it's very important that order matters, and you have to distribute the negative to the second polynomial, the one that's being subtracted from, right? Because here we had 5y squared minus y plus 3 from, right? That from, that tells me that the negative is going to have to get distributed to that polynomial. All right, multiplying polynomials vertically, horizontally, and with the box method. So let's quickly review how to multiply two numbers, right? So the same process that we use to multiply any integer is going to apply multiplying polynomials vertically, right? 4 times 3 would be 7. 4 times 2 is 8. We put a 0 for the placeholder, and then we do the 10 spot, right? So 1 times 3, 1 times 2. And then we add vertically. 8, 9, 10, 11, 3. Okay, so this same process is going to be used for multiplying in a vertical format. So let's see. So negative 2x squared plus 3x minus 6. We're going to multiply that by negative x minus 2. Okay, so the idea is that I'm going to take the first, or the last term rather, the constant, and I'm going to multiply that to every term in the top polynomial. So negative 2 times negative 6, positive 12. Negative 2 times 3x, negative 6x. And then negative 2 times negative 2x squared. So 4x squared. And basically, we leave a space, right? And I mean, I guess technically we could put a 0 to hold the spot. But now we're going to take the next term and multiply it against everything in the top polynomial. So negative x times negative 6 is positive 6x. Negative x times 3x, negative 3x squared. And then negative x times negative 2x squared. That would be positive 2x cubed. And then we add vertically. 12 positive cancels, x squared, and then 2x cubed. So we're going to get 2x cubed plus x squared plus 12. Okay, horizontal format. This is probably the most common one that everyone is used to. This one's going to look a lot like the FOIL method. This wouldn't necessarily be FOIL because we have a binomial and then a trinomial, right? 2 terms and then 3 terms. So x plus 3, 3x squared minus 2x plus 4. All right, so everything in the first polynomial is going to get multiplied to everything in the second. So we're going to get these little arcs going. So 3x cubed, negative 2x squared, plus 4x. So that first term got multiplied to everything in the second. Now we'll go with the second term in the first polynomial, right? 3 times 3x squared. 3 times negative 2x, so negative 6x. And then lastly, be plus 12. So notice it wasn't exactly FOIL, right? Because we did 6 things. Normally in a binomial times a binomial, you would use FOIL, first, outer, inner, last. Here you have 2 extra terms. So now we'll combine all our like terms. So 3x cubed, 7x squared, negative 2x, plus 12. Our next is using the box method. I would say this is pretty common also. I guess once you start to get comfortable with multiplying, the box method typically becomes, I guess, less used, but it's still very effective. We have 3 terms times 2 terms. This means when we set up our box, we're going to get, or boxes rather. Okay, so we have the 3 terms up top and the 2 terms on the side, and now we treat it like area, right? So 2 x times 3x squared. Remember, when we multiply common bases, we're adding the exponents. I guess that's worth mentioning. 4x squared, that's positive, negative 8x. All right, second row, negative 21x squared, negative 14x plus 63. All right, here with this particular method, notice that the first box, top left, and the bottom right box are typically going to be are typically singled out, right? Like there's no other x cubed, just like there's no other constant. It's always those two boxes. And then basically we'll add the diagonals. So that's where the combining like terms comes into play. So this is going to be negative 17x squared, negative 22x plus 63. Okay, now we're just multiplying three binomials. So we can pick any two, we'll FOIL it out, and then we'll multiply by the third one, and that'll basically be what we did in number 6. All right, so x minus 5, x plus 1. So first, outer, inner, last. Combining like terms, we get combining the middle two. And now we multiply by the third binomial, which is going to be x plus 3. Now, do we have to put x plus 3 in the front or in the back? It's all preference, right? Me personally, I prefer putting it in the front. And every term in the front polynomial will multiply against every term in the second. So x times x squared, we add the exponents x cubed. X times negative 4x, negative 4x squared. X times negative 5, 3 times x squared. 3 times negative 4x. And 3 times negative 5. Last step, we'll combine all of the like terms. Again, the first term and the last term are what they are, right? There typically isn't going to be multiple of those. So x cubed, x squares, we'll get 1 negative x squared, negative 17x, negative 15. All right, so with multiplying, it's very important that you set up some sort of method so that every term in one polynomial gets multiplied by every term in the second polynomial. And if there's a third and fourth and so on, just every term has to multiply with every term in the other one, so to speak. All right, so hopefully you got something out of this. Again, I'm always down for subscribes and likes and comments, so let me know what you guys think.